Yo guys, what is up? We are here. We are live. So, I'm looking at this Advent of Code Day 17 thing. This part B, this part 2, and so I just got to a point where I kind of like understood the problem. Where I got kind of confused. I thought like part 2 was like we have to find like a value of A such that like any program you give it will output a copy of itself. And I was like, whoa, like what the heck? But thankfully, the problem seems a lot more limited in scope than that. It basically seems that for this program, like just this one, we need to find out the lowest value of A so that the program outputs basically just like this string of numbers. So I just wanted to stream a little bit and like actually go through like what this what this program actually does, because I don't understand it yet, and I feel like to solve this problem we actually do need to understand what this program does. At least that's my hypothesis. Because like part 1 was like determine what the program is trying to output. You just basically code up an emulator for this system, and you don't even like really care about what this program does. You just like code it up, feed the input, get the output, and then paste it in. But now we actually have to like know what this thing does. So let's look at it. Let's see, make this a little bit bigger. Make it a lot bigger. Let's see. Probably gonna need some room over here. Let's do this down in there. Oh yeah, let's just crunch this thing way down. Okay. About that. This. Okay, so let's get this going. All right, let's see if we can see what this program does. So the program, these programs are basically like, dang, I gotta reset this thing again. Let's remove it. That didn't fix it, right? Okay, cool. I think it's pen settings. Let's go mapping. Yeah. All right. Cool. We're back. We back. I might actually go. Let me test out light mode too. Just see if it'd be better to. Oh, it's so bright. It'd be okay. Maybe I can just use a white thing here. Yeah, let's use like white. Yeah, it's drawing it with like white. That's good. So all right, so these programs are basically like opcodes followed by operands. So like this, maybe white's not the best color, like yellow. So like this is in, this still just looks like too bright or something for some reason. I think red's good. Yeah, I guess I'm just used to red. So this is an opcode. And this is like an operand. We can abbreviate these. So this is like a code, and this is like a rand, and this is like a code, and this is like a rand. So it might also be fun to think of them as kind of like f and x. It's like this is like the function, this is the input, this is the function, this is the input, fx, fx. This is kind of like an interesting way to think about it. Never really thought about it like that. So let's see what these do. So the opcode, all right, let's see what this program does. So the first opcode is BST, it's opcode 2, calculates the value of its combo operand modulo 8. Okay, so let's just go back to what the combo versus the literal operand thing is. So let's just keep this handy. Like, where is this? Where? Oh, it's over here. Okay. Okay, got this. Maybe keep this. Okay. Yeah, I'm noticing on stream. Just gotta keep it somewhere. I guess like down here is like fine. It seems okay. Right here, maybe something like that. I don't know. But is this gonna? Okay, hold on. This is kind of maybe just keep this down here, and we won't. Let's just scroll this thing up a little bit. That's fine. So now we can go to these things. Okay. All right. So this first thing is, oh wait, let's put those back. All right. So this first thing is a 2. It's a BST. This is like a BST, and the combo operand of 4 represents the value of the register A. So this first thing is basically like, I guess, so it's like, maybe we can do this, like BST of A. Yeah, maybe it'd be helpful to write it out like this. I guess we'll find out. So BST of A, which means to calculate the value of its combo operand A modulo 8. And then write that into the B register. So it's like this kind of thing. So this is basically like, I guess it's kind of like, it's kind of like we do 8 modulo. It's almost like, I don't know, we like shift it over 3 and the result of that goes into B, say. So then the next one, the opcode 1. So there's a BXL. Yeah, so there's a BXL, calculate the bitwise OR of register B and the literal. So this is a literal operand, BXL, B and this thing. So yeah, BXL, the bitwise XOR of B and, okay, so it's basically like B bitwise OR of 5. then writes that value into the B register. Okay. Okay, so we should have written down BXL of the literal, which is 5. BXL of 5. Okay, marching through here. So now we want 7, 5. So this is a CDV thing. So it's a CDV of ADV, except the thing goes in the C register. So ADV is like division. So it's basically like A divided by 2 to the combo. So the combo is 5, register B. So it's A divided by 2 to the B. Is that right? Numerator is A. 2 to the power of B. Yeah. So an operand of 2 would divide A by 2 to the 2. Yeah. 5 is 2 to the B. Okay. Written to the A, but it actually goes into C. CDV, I guess, of like B. Yeah. Okay. All right. Let's keep rolling. Yeah, 4 or 5. Opcode 4 is okay. BXC. BXC, the bitwise OR of B and C. That's pretty simple. B. Let's write bitwise OR as this instead. B bitwise OR C, BXC stores the result in the B. BXC just has no operand. Okay, now 0. Okay, so now this is an ADV. So 0 and 3. So this is an ADV. It's kind of like the CDV. So it's A divided by 2 to the combo operand. So it's 3. So it's just 2 to the 3. And this goes into A. Okay, so there's only 1, 2, 3 more instructions. ADV of 3. Okay, now there's a 1 here. There's a BXL, I guess, again. It's kind of like this back here. So it's a BXL of, yeah, the bitwise OR of B and the literal. B and the literal. 1, and the literal is 6. So it's B bitwise OR the literal of 6. And BXL goes into B. I guess, kind of think these are like comments, I guess. BXL of 6. Okay. 5, 5. Let's see. 5, 5. We have to get to a jump instruction here. Don't we eventually, no? So 5, 5. So 5 is the out. This one should probably be simple. Out. Combo operand mod 8, and then output the value. So the combo operand of 5 is B. So it's B mod 8. So it's just the last 3. It's just the last 3 like binary digits, I guess. like b mod 8. And this is just like, I don't know, this is like out to the screen. Okay, and then the last one is just 3.0. Yes, JNZ. Okay, it does nothing if A is 0. However, if A is not 0, jumps to the instruction pointing to the value of the literal operand. Okay, interesting. So I think literal operands, how big can they be? It's a list of 3-bit numbers, so it's never higher than 7. And there's only 0, 1, 2, 3, 4, 5, 6, 7 like values here. 0, 1, 2, 3, 4, 5, 6, 7. Wait, so how does this thing ever end if the last thing is a jump instruction and I guess if okay. If the value in A is 0, then we end. Okay. So okay. So the last one is 3.0. JNZ does nothing if A jumps to the instruction and the pointer to the little operand. If it jumps, then the instruction pointer is not increased. Okay. So this just does a JNZ of JNZ of 0. Yeah. So this is like it's almost like jump to 0 if A is equal to 0. I don't know. I guess you could say that. Okay. Cool. I think something cool to do next would be to modify the program to print out the instructions and just like see if it, let's just verify that it matches these before we do anything else. Let's save this right here. And let's go. I feel like there's a size that I like, but I'm not really seeing it right now. It looks kind of weird. Yeah, I'll just keep the text on here. Let's see. This was day 17, right? Let's just get rid of this right here. All right, so we got this thing, and so basically when we're going through, let's print out like a representation of this. So for ADV, we get the combo operand, we do the result. So let's just print out like ADV and the, I guess we kind of want to print out like a string version of the combo operand. So maybe it's like get combo string, and what do we call this? Just passed it an operand. Okay, so now we can just kind of go by what these were. So we should say, I think it's going to be actually very similar to just like the get combo here. So it's basically going to be this. It's going to be like, if the operand is less than 3, just return the operand. If the operand, yeah, we'll just return string versions of these. Okay. So let's do ADV, and then the get combo string, right, of the operand, and that's it. Yeah. So it's fine for that one. So we're doing it after the result. So the BXL is the bitwise OR. BXL is the bitwise OR of B and the literal. So we just need to print BXL of the literal operand. That's fine. And then we have like CDV. Well, I guess we can kind of go through. All right, so BST. Actually, do we even need to look at the? I don't even think we need to look at the instructions. Like we can just go by the code. So we should just be able to print BST and the get combo string. So now the JNZ, just print JNZ of, do the literal operand, right? So that's just the operand. We just have that there now. The BXC. So yeah, I guess it's just like B and C. So print BXC, and I guess it's just B and C like this. BXC, did we? I guess BXC doesn't really even have a thing. It's just implicitly B and C, hard coded. Out. We get the combo operand, and we modify 8. So I guess it's just get combo string operand BDV, and again we're getting the combo, so let's get combo string operand, and then CDB here, and that's again getting the combo operand, get the combo string. So let's see if this works. So this is our program here with the 3.0, the 5.5 thing. So this is just kind of looping. I think if we put it set value A to this value, then wait, is this going to make a difference? Is this a different value? No, this is the same value. So does this thing actually just loop forever, or like what was part 1? I don't remember what part 1 was. Part 1 was just like, what does this thing output? So, okay, so B, I think I'm already doing this while true thing. So yeah, I don't want to hard code A. I just want to, yeah, so we just get the registers. Okay. So we're not going to brute force this or anything. So let's just put this thing back. So we got the registers. So let's just print out screen. So we're just running this once. Okay. I guess what we're doing is a little bit weird. It's like we're printing out the program while we're running it. So we're actually printing out like a trace of the program that's running. We're not just printing out like a copy of the program. I guess we kind of want like another kind of like copy of the program. But anyway, like I don't know, it doesn't sound too interesting. That just kind of sounds like more work. Let's just kind of match these up and let's see if they line up. So, all right, we got BST of A, that's good. BXL of 5, that's good. CDV of B, that's good. BXC, ADV of 3, BXL of 6, out. We said out B. Okay, I guess it's probably just like hard coded to B whatever, and then JNZ 0. And then we kind of like loop back up to BST of A. And I think we just like keep printing this out over and over again. Okay, so that's a good sanity check. So I guess I feel like the next step is just to kind of stare at this and let's see if we can grok like what it's actually doing. So if we just, I don't even know like what to call this, but okay, we can just grab like the first up until the JNZ. Just grab these. So this is basically doing like B. I want to get this Unicode left arrow thing. Feels fancy. Maybe. B. So A bit shifted 3. B XOR of 5. Let's do this as these comments instead. CDV of B, C, A divided by 2 to the B. This is a cool, we can sub equals all. Let's just place these. Okay, so BXC is B and B XOR C. ADV of 3 is A divided by 2. Let's do this. Yeah, 2 to the 3. And that goes back into A. The BXL is B and B bitwise OR with 6. I guess the out would just be B mod 8. Let's get this goes out to the screen. And then JNZ is JMP to 0 if A is 0. Let's save this as test program. So is this the way to Yeah. So okay. So kind of looking at this, it's like so um we need this to output like this sequence of things. So we needed to output a 2 and then a 4 and then a 1 and then a 5. And so we kind of like maybe we can start looking at it like let's see. Let's get rid of this stuff. Just watched the season finale of Shogun, by the way, and like, dang, that song is just, yeah, like the theme song is just like ringing in my head. Pretty intense show. No spoilers, but yeah, pretty crazy. So let's see. So this first thing, so the BST and then the BXL. Okay, let's see the out thing. The out is like the second to last one. So this is the out, and this is the JMP, which kind of brings us like back to this is a literal. So it's fixed. So this will always just bring us back to the first thing here. If A is not 0. So what we need this to do is this got to output like this value is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So basically it needs to run 16 times. And then on the 16th time, A has to be 0. And then we're like done. So I guess it's almost like what happens to A. Like if A just like kept getting like divided by 2, like over and over, then if A was like 2 to the 16th power or like 2 to the 15th, then after like 16 times it would be 0 and then we would, we'd be good. But let's kind of see what actually happens. Maybe it's kind of good to draw it out in terms of registers. Like there's like the A register, it's the B register, the C. And so, yeah, these all have initial values. And so A gets divided by 8, right? Yeah. So A gets shifted over 3. So I don't know. Yeah, let's say that A started off as like 256 or something. Um, I don't know. Let's say A starts off as like 1 0 0 0 0 0 0 0. So like this starts off as A like this, and so A is in this case it's 2 to the 0, 1, 2, 3, 4, 5, 6, 7. So A is 2 to the 7. 2 to the 5th is 32. 64. 2 to the 6th is 64. 2 to the 7th is 128. Okay, so let's say it starts off as 128. So it gets shifted over 3. So 1, 2, 3. So this becomes a 1, and like these get chopped off basically. So A is now, let's see, 2 to the 0, 1, 2, 3, 4, 2 to the 4. So A becomes 16 now. Yeah, because that would be 8. So now B. Okay, now we're doing like bitwise orange stuff. I know like swapping two values, you kind of like bitwise OR them together like 3 times or something, and they swap the values. So I kind of see that as maybe jumping out like bitwise OR, bitwise OR, bitwise OR here. Maybe like B and C are getting swapped somehow. But so B needs to get bitwise OR with 5. Yeah, so B is going to be whatever. CDV of B gets raised to like 2 or like 2 to the B power. So that's like whatever, 1 followed by a bunch of zeros, and then A gets divided by that. What does it mean to divide A by like a power? Like if you do A divided by 2, like that is, well, let me think about it in base 10. Like if you have 1,000 and you divide that by 10, I mean like 10 to the 1, then that just like knocks off like a 0. If you divide it by 10 to the 2, then that knocks off 2 zeros. If you divide it by 10 to the 3, that knocks off 3 zeros. So in this case, if A is 2 to some power, then A divided by 2 to, so it's not exactly this, but it's like if we have like 2 to the A and we divide that by 2 to the B, say, then this should just be 2 to the like A minus B, basically. Just like subtract like B-A's, B2s away, whatever. So this, so this kind of has the effect of like knocking off some zeros. And then we bitwise OR again, like B and C. And then we do ADV of 3. So we do the same thing where it's kind of like 2 to the A divided by, yeah, I think was ADV literal? Was division literal? ADV, no, it's a combo. But that's never going to change because the program's fixed. So it's always going to be 2 to ADV of 3. Yeah, only A and B are kind of like can change here. So ADV of 3. So you're okay. So we're always going to be like shifting over 3 bits. Okay, yeah, this one's a little bit simpler because we're always just like shifting over 3 bits. I think we should even update that because that would be kind of simpler. Shifting over 3 bits, basically. And then we have the BXL of 6, which says B bitwise door with 6. And then that goes into B. What are these bitwise OR things? We're doing this as 5, it goes into B, goes into B, goes into B. It goes into B every time. Yeah, and let's change the screen thing too. Let's also do this is like this shifts over 3. It's like 2 to the 3rd as well. So yeah. So kind of curious if this power is 2 to something. Like if we take log base 2 of this, is this, no, I mean, this is an odd number, so it's not going to be a, we're doing integer division and stuff, but let's see. Still don't have like a great intuition for like everything that's going on here. I think drawing it out more could help us get better intuition. So we basically like take A and we shift it over 3. Maybe think about it in terms of like A, B, and C like this. And so B basically gets like A shifted over 3. And then B gets this thing. And then you kind of like bitwise or this thing, and you get, you bitwise or this with 5. Bitwise or with 5. And so you get, I don't know, you just call this like A2 or something. And then we do A shifted over, okay. Instead of A divided by 2 to the B, we can just shift it over B times basically. So we do A shifted over B and we do that into C. So shift over B times, and this becomes like C of 2, I guess. And then we do B and C. B and C bitwise OR and do that into B. So it's kind of like we take this and we take this and we like bitwise OR it and it goes into B. This is like B of 2 or something. Okay. And then we take whatever's in A, this thing, and we shift it over 3, and that goes into A. So we kind of shift it over by 3, and this becomes like A3 or something. And then B gets bitwise OR with 6. So we kind of like bitwise OR with 6, and that becomes like B3 or something. And then we do out. I guess you can kind of think we could just do this like out to the screen here. We do the B shifted over by 3, and this just goes out to the screen. Like B3 is kind of like the screen like output over here. No, this is the screen. And I guess the screen could go kind of from left to right. So it's like B3 is the first value that gets put out. And then we go back to 0. And then we just like jump back to 0. And we kind of do the same thing. It's like, so now we like take whatever values in A, just like A3, and we shift it over 3. And yeah. And then the value of B here, this thing gets bitwise OR with 5, and then just, it gets put into B. Okay, I guess this was a mistake. Like this doesn't, it gets bitwise OR with 5, but it doesn't go into A. It stays in B. So this should be like, so it like bitwise OR with 5, and then this becomes like B1 or something. And then we do like A and B, like these two. So like this B4, this like bitwise OR with 5, and then we do these guys. Yeah. So kind of sort of thing. So anyway, this is kind of my first attempt to see if we can suss out some kind of like pattern or setting. I feel like the next thing that we should do is we should write out, um, if we start off with values like A, B, and C. So like after one iteration of this, what are the values of A1, B1, and C1? And like, what are the values that got put out to screen? Um, S1, I guess. And then can we like predictably kind of predict what like A2, B2, and C2 are going to be? And then do that, S2, what's it going to be? So I think if we could do this next, then we'll be able to take the next step from there. So yeah, I feel like I'm gonna take a break. I'm gonna go take a shower or something. That was fun. It's cool, kind of like brainstorming and like mapping all this out. I'll be back, to do this soon. Finish it up, hopefully. And thanks for hanging out, guys. Thanks for watching. This was cool. See you next time. Peace.